Okay, today we're going to look at the unit circle. We've been talking about right triangle trig last year, and of course we revisited this year before the break. So unit triangle is a triangle whose hypotenuse is 1 unit in length. To find the exact sine and cosine values for specific measures of theta, we must use special right triangles and right triangle trig. So we're going to find the lengths of the sides given the unit triangle. So we're saying we want this to be a length of 1 because it's across from the right angle, which means this is the hypotenuse, right? Same thing here, this would be 1. So recall, these are our 30, 60, 90 triangles, but we didn't write it like this before. We just said that, this was the leg and this was the leg root 2. So this was the leg. So then here, instead of just saying leg, we have an X, right, instead of leg. So if you want to write leg, you can, or you can use the X. But how do we make that into 1? Well, if it's x root 2, then we would divide by x root 2. So x root 2 over x root 2 then equals 1, which is our hypotenuse, right? It's across from the right angle. So then the legs of the triangle would be 1 over the square root of 2, but we don't like to have radicals in the denominator, so I would rationalize this, which gives us root 2 over, and this would be the square root of 4, which is just 2. So this would be root 2 over 2, and both the legs are the same, so root 2 over 2. What happens if we have a 30, 60, 90 triangle? So this is leg times 2, this is leg, and leg root 3. So if this is 2 times the leg, again, you're just dividing by 2x here. So 2x divided by 2x is equal to 1, and this would give us 1/2 and root 3 over 2. So across from the 60 degrees is the root 3 over 2, and across from the 30 degrees is the 1/2. Okay. So let's think about then what a unit circle is. A unit circle is a circle with a radius of 1 unit. Because the value of r is 1 for each point p, x, y in the circle, the sine, cosine, and tangent values are for theta are defined as the following. So remember, theta is just the angle that we have. So to get to this point, we're going over x distance and up y. So sine, remember, is the opposite over the hypotenuse. So the opposite of the angle is across from it, so that's y. And the hypotenuse in this case is 1, so y over 1 is just y. So then the next one is the cosine. So remember, cosine is the adjacent over the hypotenuse. So the adjacent of the angle now is what's next to it. So x over 1, which is equal to x. Then tangent is the opposite over the adjacent. So the opposite we said was y, the adjacent we said was x, so y over x, which you could also say as the sine of theta over cosine theta. So then the coordinates of P can be written as, of course, if this is x comma y, you can then say that x now is the cosine of theta, and y is the sine of theta by what we just showed here. So how does this relate to the unit circle? So, and the special right triangles is how do they relate to the unit circles, what I'm trying to get at. So the diagram below shows a right triangle ABC placed on a unit circle centered at the origin. The central angle measures 30, 45, and 60 are shown. Label each triangle in exact form using the unit triangle measures we just found. So remember, for the 30, 60, 90, across from the 30 was the 1/2, and across from the 60 was a root 3 over 2. So across from the 30 is the 1/2, and that makes this then the 60 degrees, because that's the 90 would be the 1. So this would be root 3 over 2. So then for 30 degrees, if we want to put this in radians, we can multiply it by pi over 180, and then just plug this into decimals to get the simplified answer, which is pi over 6. So then we want to find what the cosine of pi over 6 is, or the cosine of 30 degrees. So the cosine of this angle is the adjacent over hypotenuse. Root 3 over 2 divided by 1 is just equal to root 3 over 2. Then the sine is the opposite over the hypotenuse, so the opposite's 1/2 divided by 1, which is just 1/2. So then what are the points of P on this? You can even look at the triangle. We're going over root 3 over 2, up 1/2 to get to that point. So root 3 over 2, comma, 1/2. So that means that the cosine of 30 degrees is root 3 over 2. The sine of 30 degrees is 1/2. So 45 degrees, remember if we go back to our unit triangle over here, we had root 2 over 2, root 2 over 2, 1. Just going to write the sides down here. So for 45 degrees, if we multiply this pi over 180, we get pi over 4 for the radians. So the cosine of 30 degrees, or the cosine, if you want to write out, so the cosine of 45 degrees would be the adjacent over the hypotenuse. So the adjacent's root 2 over 2, hypotenuse is 1. So this would just be root 2 over 2. And then the sine of 45 degrees would be equal to the opposite over the hypotenuse, which is root 2 over 2 over 1, so root 2 over 2. So then the point would just be, for x and y, you're going over root 2 over 2 and root 2 over 2. So then let's do our 60-degree angle for the standard angle that we're using. So the first one was using 30 degrees for the standard angle, and this one's using 60. So that changes the way our values are. So across from 60 is the root 3 over 2, across from 30 degrees is the 1/2, and the hypotenuse is 1. So if we want the radians, multiply that by pi over 180. So when you do that, that gives you pi over 3. And again, you just plug it into decimals without the pi and hit the fraction key to get 1/3 or pi over 3. So the cosine of 60 degrees or pi over 3 then would be the adjacent over hypotenuse. So 1/2 divided by 1 is 1/2. And the sine of 60 degrees would be equal to root 3 over 2. So this would be 1/2, comma, root 3 over 2. And notice these coordinates are opposite, which makes sense since you're, instead of using the 30 degrees, you're using the 60, but they're from the same triangle, right? So how does this relate to beyond the first quadrant? So if we're using these reference angles of 30, 45, and 60, well, in the other quadrants, then that means this here would be the triangle, right? And this would be the triangle that you're using, and this would be the triangle, because these are all then 30 degrees here for the reference angle. So if the reference angle is all 30 degrees, then what's the only difference in the different quadrants? You're just basically changing the sign. So in the first quadrant, your x is positive and y is positive. In the next quadrant, x is negative and y is positive. Oops, just write it plus. If you were to plot a point in third quadrant, x and y are both negative, and positive x and negative y. So then the only thing that changes are the signs. So if this point is root 3 over 2, 1/2, then over here, in the next quadrant at 150 degrees, it would be negative root 3 over 2, 1/2. Then at 210, it would be negative root 3 over 2, negative 1/2. And then positive root 3 over 2, negative 1/2. So notice that it's the same point because we're using the same reference angle, 30 degrees, for each of these triangles. So the only difference is that we are changing the sign that we're using. So same thing for 45 degrees. So this would be a 45-degree reference angle for each of these. And so that's using the root 2 over 2. So in quadrant 2, which is the 135 degrees, it would be negative root 2 over 2, positive root 2 over 2. And then in the next quadrant, which is again quadrant 3 down here, this is quadrant 4, so quadrant 1, quadrants 2, 3, and 4, it would be negative, negative, so negative root 2 over 2, negative root 2 over 2. And then in quadrant 4, it would be root 2 over 2, negative root 2 over 2. So then the 60 degrees is the same, except for we're using this triangle here, here, and here. So this is using 60 degrees for our reference angle for all of these. So again, we're just changing the signs, negative 1/2 root 3 over 2, and then negative 1/2 negative root 3 over 2, and then 1/2 negative root 3 over 2. So it says use the angles found above to label your unit circle. So now we're just going to put this on our unit circle. So that's that last page that you have. So we'll go down here. So the signs are for quadrant 1, we said positive for both x and y. then it's negative x, positive y, negative x and y, and then your quadrant 4 would have a positive x and negative y. So we already have the degrees and the radian measures on our circle. Let's go ahead and just fill in those points that we just did, so you can just copy them down from what I have. The only ones we didn't do were the quadrantal angles, which is on the axes. So we have 1, 0, right? Because if this is the hypotenuse, if it's a unit circle, the radius is 1. So that means we're going over 1 up 0. So then that means for this one, we would be going over 0 and up 1. Over here, this would be negative 1, 0. And then down here would be 0, negative 1, because we're going over 0 and down 1. So then let's go ahead and look at 30. Goes along with 210, 150, and 330. Those are all the same value. So this was root 3 over 2 and 1/2. Negative root 3 over 2, 1/2. This would be negative root 3 over 2, negative root 3 over 2, or sorry, negative 1/2. And then this would be root 3 over 2, negative 1/2. So again, notice the same point. We're just using, or just changing the signs. So all these middle ones are going to use the same point, root 2 over 2. So here, this would be negative, or root 2 over 2, positive root 2 over 2, and then negative and negative, and then positive and negative. And then the last one we have is our 60-degree values. So for this one, this would be 1/2 root 3 over 2. So this would be negative 1/2 root 3 over 2, negative 1/2 negative root 3 over 2, positive 1/2, and negative root 3 over 2. So again, if you know the first quadrant, you know the rest of them, but you guys don't have to memorize this, you just have to know how to use it. So let's go ahead and look at how to use it. So I put up here a unit circle, so let's go ahead and look at that. So a quadrantal angle is an angle whose terminal side lies along one of the coordinate axes, like we said. So we have 0 degrees, 90, 180, 270, and then in radians, that's 0, pi over 2, pi, 3 pi over 2, so this is 0. That's already labeled, so pi over 2, pi, and 3 pi over 2, 0. So then the sine of 0 degrees or 0 radians, the sine, remember, is your y coordinate, so this is equal to y. So on my circle, what's the y coordinate here? The y coordinate is equal to 0. The cosine, of course, is the x coordinate then. So what's the x coordinate? Maybe I should do this in a different color, is 1. So then what about the sine of 90 degrees? Or pi over 2. So 90 degrees is here. The sine is the y coordinate, so that would be 1. And then the cosine would be 0. So at 180 or pi, we would say the sine of 180 degrees, or pi, you could write sine would be the y coordinate, so that's 0. And then the cosine would be the x coordinate, -1. So the cosine of pi, or 180, is -1. So at 270, 3 pi over 2, the sine is -1. So I should use green. -1. And the cosine is 0. And so that's how we get those values, is by using this unit circle. It helps us give us the exact values that we have. You just have to remember that cosine is x and sine is y. So cosine of the angle, sine of the angle. So it's x, y. And an easy way to remember that is y comes before, or sorry, x comes before y in the alphabet, c comes before s. So let's go ahead and look at the next one. It says, find the exact value of the following using your knowledge of the unit circle. So this says the sine of 45 degrees. Well, where's 45 degrees? Here. Sine is the y coordinate. So what is the y coordinate? Root 2 over 2. Then we look at the next one, cosine of 150. So 150 is here. Cosine is the x coordinate. So what's the x coordinate? -root 3 over 2. Going to the next one, we have 210. We want the sine, so -1/2. Cosine is 300. So here's 300. Cosine is the x-coordinate. So the cosine of 300 degrees would be 1/2. Then the next one we have a radian measure because there's no degrees. So 5 pi over 3, which is the same as 300. So we just said the cosine of 300 was 1/2. So the cosine of 5 pi over 3 is also 1/2. It's that same value here. The next one we have then is the sine of 4 pi over 3. Here's 4 pi over 3. The sine is the y-coordinate, so negative root 3 over 2. Then we have 2 pi over 3, so the cosine of 2 pi over 3 is here, and here's this value, so negative 1/2. And the sine of 11 pi over 6, here's 11 pi over 6, the sine is the y-coordinate, so negative 1/2. So that is how we use our unit circle to find these values. You just have to remember that again, sine is always going to be the y-coordinate, cosine is x. So y-coordinate, x-coordinate, x-coordinate here, y-coordinate here, x and y. And then you just, again, you don't have to memorize the circle, but you just have to know how to use it. And that is all for this lesson.